In the next 7 minutes, you are going to make a program that blinks this LED on and off using your Arduino's digital outputs. Hi, my name is Jeremy, and welcome to the first tutorial in a series of videos aimed to teach the basics of using an Arduino microcontroller so that you may compete in this semester's Solid State Circuit Society Arduino contest. More information available in the link below. If you have not already, check out our previous video where we set up the Arduino software on our personal computer. Here is an Arduino Uno. It is made up of an Atmega chip, otherwise known as the brains of the board, as well as input and output ports used to communicate with the outside world. Today, we will only be focusing on the digital outputs. To make this project, you will need a breadboard. Breadboards are used to build electrical circuits without having to solder wires together. It is made up of several holes which are connected to one another in this pattern. We are also going to need a light emitting diode, or LED. Similar to a light bulb, an LED generates light when electricity passes through it. If we look closer at the device, you will notice one of the metal leads is longer than the other. This is the positive side. The short end is the negative side. LEDs are a type of diode. A diode is a device that only lets electricity pass in one direction. You can think of it as a one-way valve. If we connect the positive lead to the positive side of the battery and the negative lead to the negative side of the battery, electricity will flow and the LED will turn on. However, if we flip the LED, the flow of electricity will stop and the LED will turn off. This being said, we must be careful. Letting too much electricity pass through the LED will burn it out. To avoid this, we can reduce the flow of electricity by adding a resistor. But what size resistor should we pick? In electronics, there is a very well-known equation called Ohm's law. It states voltage equals current times resistance. Let us rearrange the equation to solve for R. The Arduino's digital outputs use 5-volt logic. An LED will break if the current exceeds much over 20 milliamps. This tells us we need a resistor of around 250 ohms. Now, resistors may look alike, but their resistances can vary substantially. In order to find the correct resistor, we must look at the color bands on the side. Resistor values are specified using scientific notation. In our case, 250 equals 2.50 times 10 to the exponent of 2. From this table, we can see this corresponds to red, green, black, and red. And assuming a 5% tolerance, gold. Next, let's build the circuit. Make sure to unplug your Arduino to avoid shorting any components. Take your LED and plug it into the breadboard as shown. If you do not have a resistor that is exactly 250 ohms, you may use one with a similar value. I will be using a 220 ohm resistor. However, do so with caution. Using too large of a resistor will reduce the LED brightness, whereas using too small of a resistor may risk burning out your LED. Finally, grab 2 wires, connect one side to ground and the other to one of the digital output ports. I will arbitrarily be using port 13, but you may use any of these ports. Next, we will write the code. Open the Arduino program. Begin by writing void setup. This function will be executed only once the moment the Arduino is turned on. Next, write void loop. Once the program executes whatever is inside the setup function, it will proceed to the loop function, where it will execute whatever is inside this function repeatedly forever, as long as you keep the board turned on. All Arduino programs are structured with these 2 main functions. For this program, we will be getting an LED to blink on and off repeatedly. We begin by initializing port 13, or whichever port you have chosen, as a digital output. Within the setup function, write pin mode 13 output. This is a built-in Arduino function where the first argument specifies the port number and the second specifies whether this port should be an input or an output. Make sure to terminate every command with a semicolon. Next, we will create our loop. The loop will simply turn on the LED, wait 1 second, turn off the LED, wait another second, and repeat indefinitely. To turn on the LED, type digital write 13 high. This function has two arguments, where the first specifies the port number and the second specifies whether to set that output as high or low. Next, add a delay. Type delay 1000. This delay function is specified in milliseconds, so 1000 milliseconds is 1 second. Next, turn off the LED. Type digital write 13 low. Finally, delay another second with delay 1000. And you're done. To run the program, plug in your Arduino into your computer and click on the Upload button. This will compile your program and send it to the Arduino. The compiler will catch any mistakes and ask you to correct them. If successful, your LED should begin to blink. If so, congratulations! Feel free to play around with the digital write and delay functions. I challenge you to take what we have learned today and create a red, yellow, and green traffic light. Join us next video when we will add to our program by getting this push button to control our LED.